Hello everyone. Today I will be presenting on motion estimation and object tracking. These two topics form the foundation of modern video analysis systems used in surveillance, robotics, traffic monitoring, and many intelligent visual applications. So we'll start with the introduction. Motion estimation refers to identifying moving objects between video frames, while object tracking is a process of following those detected objects over time. These techniques allow systems to understand the movement, detect activities, and make intelligent decisions like moving the objects with surveillance of the robotics, traffics, monitoring, and etc. They are widely used in surveillance cameras, human computer interactions, self driving cars, and even sports analytics. Main usage of the camera analysis is to track the frames. So, the next slide, we are going to say why motion estimation is used. So motion estimation is essential for various categories. So motion estimation is essential because it allows us to detect moving regions automatically. By understanding the motion, we can analyze object behavior such as the speed of the frame, direction of the speed, direction of the frame, or unusual activities. This is especially important in surveillance where automatic systems must detect abnormal events without human intervention. It also forms the basis of many intelligent visual systems, enabling machines to interrupt scenes in real time. It also supports understanding the object's behavior, etc. And then in the next slide, we are going to tell about the background modeling. Background modeling. The first major step in motion estimation is the background modeling. The first main step is the background modeling. This involves separating the static background from moving foreground objects. In video surveillance, background subtraction is one of the simplest and most effective techniques. By modeling what the scene normally looks like, we can detect when something changes, such as person entering a room or a vehicle passing by. So by minusing or subtracting the background, we could able to find out each object or the persons that is moving in a video or in the frames. So, in the next slide, we are going to tell about the background subtraction techniques, which are mainly the temporal differencing, single Gaussian model, Gaussian mixture model, GM, and the dynamic backgrounds, like that. So, there are several commonly used methods, such as the first one, which is known as the temporal differencing. This compares consecutive frames to detect changes. It works well for fast moving objects but can struggle with slow or stationary ones. That's about the temporal differencing. Now, for the second one, the single Gaussian model, here each pixel is modulated statistically, but it cannot handle variation very well. That's what about the single Gaussian model. The third one, the third technique which is used is Gaussian mixture model, GMM. This is one of the most widely used techniques. GMM can represent dynamic backgrounds such as waving trees, rain, or flickering screens. That's why it is popular in world CCTV systems. So this GMM is the main technique which can handle dynamic backgrounds, which helps to subtract them and it's used in CCTVs. So the next slide, we are going to tell about the object tracking. Object tracking is also one of the important part in motion. So once moving objects are detected, the next step is tracking them over time. After the object is detected, then step is tracking it one by one in frames over time. So object tracking maintains the identity of each object across frames and helps analyzes motion patterns. This is crucial for applications like pedestrian tracking, vehicle tracking, or crowd behavior analysis. So it is mainly used to track the objects in each frame, which may have a loop of frames, and it gives the output as the object in each frame. In the next slide, we are going to explain about tracking approaches. What all tracking approaches are there to find the objects? So there are several major approaches to tracking. The first one is the model-based tracking. The model-based tracking uses predefined models of objects to track the objects. The next one is a contour-based tracking. It focuses on the shape or boundary of the object. It tracks the object by identifying the shape, if it's a oval, it's a circle like that, or boundary of the object. It goes on monitoring the boundary, which can lead to various substances. The next is the feature-based tracking. It mainly uses the characteristics such as color, edges, texture, or corner points to find out the object. Choosing the right approach depends on the environment and object type. So these three models are always different. So choosing the correct type of model is very important to find the object correctly. In the next slide, we are going to explain about the mean shift tracking. Mean shift is a simple and a popular tracking technique. It finds the regions with the highest density of features, essentially moving a window towards the object in each frame. While it is easy to implement and work well for slowly moving objects, it struggles when objects move quickly or change shape significantly. So the mean shift tracking mainly cannot be used for fast moving objects because it cannot identify the objects that move too fast, because the frames go on looping out and cannot find the correct object or correct time, our correct time. The next slide, we are going to tell about the particle filter tracking. Particle filter tracking. It is another type of tracking in which the particle filters are more advanced and a robust type of tracking. They model motion in a probabilistic way and operate through three main steps. So they have three main steps, which is first one is prediction, second one is measurement, and then resampling. In the first step, which is known as a prediction, it anticipating where the object could move. It predicts the output where the object can move. In the second one, measurement, comparing predictions with the actual observation. So it compares, if you take an object like a ball or a bat, it compares the shape or the measurement of that with the original one. If it gets an it identifies the object. The next step is this resampling, keeping the most likely positions. So it compares all the outputs and gives the output that is more applicable to that. This is why this makes the particle filter effective in situations involving oscillation, non-linear movement, and unpredictable trajectories. So this is one of the important tracking, which is known as the particle filter tracking. In the next slide, we are going to tell about the challenges that are faced in tracking. So there are many challenges that face in tracking. Maybe the techniques used may be not correct. Maybe the fast motion have problems. So the main challenges that occurs are, the worst one is occlusion. When occlusions occurs when object overlap or disappears behind others. If one object overlaps over the other type of objects, then it cannot find or track the object. Then the illumination changes, that is such as shadows or lighting differences come, which may cause difficulties to track the object. The next is the fast motion. Objects that move quickly may be missed because they already told that some tracking techniques cannot correctly identify the fast moving objects, which can cause them to miss the objects. Last one is the crowd scenes, multiple objects. See, multiple people or vehicles make tracking identify harder, so confusions occurs. So very crowded scenes like many vehicles overlaps each other makes it very difficult for tracking. Modern tracking systems try to combine multiple techniques to overcome these challenges. So the next one is the application. Application of the tracking and motion is very easy. So because we know that, so these methods are used widely in a real world application, the video surveillance and security, traffic monitoring and smart transportation, human activity recognition, recognizing the human activities of an human behavior, then autonomous driving, that is autonomous vehicles, identifying the kind of vehicles, uh, then counting the number of type of vehicles, identifying the number boards. That's main other one. And the robotic navigation. Robotic navigation also use the tracking, which allows them to correctly identify and process their activities. So they enable systems to understand motion and interact with the environment intelligently. So at last, for conclusion, to conclude, motion estimation and object tracking are the core tasks in the video analysis. From background subtractions techniques like GMM to tracking methods like mean shift and particle filters, these tools enable many of today's intelligent visual systems. So, I'm telling the motion estimation and object tracking can become or has the future to become the best um, core task in video analysis, which can be used to develop many models or many models or techniques that can be useful for the future purpose. So okay, that's it. Thank you. Thank you for listening. Thank you.